Let's solve a trig equation that's quadratic in form. All right, I've got the tangent squared of x minus 3 tangent of x minus 2 equaling 0. All right, we recognize that that is quadratic in form. Pretty good hint here is to make a substitution. Let's let u equal the tangent of x. And so we can replace the tangent of x with u. From this, we obtain the quadratic equation u squared minus 3u minus 2 equaling 0. Now notice, this is not factorable. We have no factors of a negative 2, whose sum is a negative 3, so we have to use the quadratic formula. So u will then be equal to the quadratic formula plugged in. We obtain 3 plus or minus the square root of 17 all over 2. Now let's consider the negative case. Remember, we use the quadratic formula to come up with u equals 3 plus or minus the square root of 17 all over 2. I want to focus our attention on the negative case, which is 3 minus the square root of 17 all over 2. Remember what u was. We let u equal the tangent of x, so we actually have the trig equation that the tangent of x now is equal to 3 minus the square root of 17 all over 2, and this value is negative. And anytime that the tangent value is negative, we know our solutions exist in quadrants 2 and also in quadrants 4. And we got to focus our attention on that. So what we need to do then is take the inverse tangent of both sides to obtain x. And when we take the inverse tangent of this mess on the right, 3 minus the square root of 17 all over 2, we come up with a value that looks something like the following. X is approximately a negative 29.3165 degrees. And again, make sure that your calculator is in degree mode when you're going for this answer. All right, negative 29.3165 degrees is really the same thing in terms of a positive angle as 330.6835 degrees. Okay, so we've sort of reversed order here where we found the solution in quadrant 4 first, and then we're going to find that in quadrant 2. Now we find out actually that our reference angle is a positive 29.3165. So if we subtract that from 360 in if we subtract that from 180 in quadrant 2, we obtain an approximate solution there as well of 150.6835 degrees. So those are our two solutions then in terms of degrees. But our solution has to be in terms of radians. So we need to multiply each of these by pi over 180. For our first solution, we get an approximate radian solution of, let me get that for you here, 5.7715. And for the other case, we get 2.6299 radians. And so there are our two solutions in terms of the negative case. Now we need to consider the positive case. That was the case where the tangent of x was equal to 3 plus the square root of 17 all over 2. And if you pile that into your calculator, you get a positive value for that. Now let's think about this. If this is positive, we have to think about in which quadrants the tangent is positive. And this occurs for us in quadrant 1 and also in quadrant 3. So what we can do now is carefully put this into our calculator, take the inverse tangent of both sides. So we get the inverse tangent of 3 plus the square root of 17 all over 2. I recommend you do this in decimals first and get an approximate answer. In this case, 74.3165 degrees. And again, that's an approximate answer in quadrant 1. Now, because this is in quadrant 1, we know that this is our reference angle, and we'll use that to find our solution in quadrant 3. In quadrant 3, in order to find that, what we're going to do then is take 180 degrees and add our 74.3165. So our second solution will be approximately 254.3165 degrees. And again, that's the 4 decimal places. All right, so we have our quadrant 1 solution and our poorly written quadrant 3 solution, but it's somewhat readable. Now, remember our directions. We needed our solution to be between 0 and 2 pi radians, so we'll take each of our solutions in terms of degrees and multiply those by pi over 180, and in doing so, we'll obtain our solutions in terms of radians. So for the first one, again, approximately to 4 decimal places, we're going to get 1.2971. For our second or our third quadrant solution, we get an approximate radian answer of 4.9387 radians, and those are the two solutions.